This is a question of application derivatives. Now you have a corridor, and this is 3 meters. This is 3 meters wide. This is 2 meters. This is 2 meters. Now the question is that find a longest post which can be carried over through this corner of corridor horizontally without tilting. Well, obviously that if the post is short, it can be carried over right easily. If the post is too long, and you cannot do so. So somewhere must exist a value of a length of the post which is just enough to carry over this corridor horizontally without tilting. This looks not easy. Okay, this corridor, right? If this is a right angle, and this is the right angle. Now, this question is when we discuss on the paper. Actually, this question becomes find a line, the red line, such that the end point touches these 2 pieces of wall and also touch somewhere in this corner. Okay. And of course, the line could be very long, right? Very long. Very long. Or the line could be very long this way, right? So somewhere there's a shortest length of the line which can do so. Touch the point here, touch that piece of wall there, touch the point there. So this minimum length is actually, this minimum length of the line is actually the longest post we can carry it over horizontally over this corner without tilting. I hope you do. I hope you understand what I mean. Let me repeat again. We are looking for the longest post can be carried over horizontally through this corner without tilting. When we analyze, actually we are looking for the shortest line such that it can touch this piece of wall, and that point at the same time. The shortest line can do so. Well, now I don't write, I just verbally express that let X be the line, be the line segment, right? Let X be the line segment such that touch this piece of wall, touch this piece of wall, touch that point at the same time. So we're looking for the minimum line, minimum length of the line. We're looking for X, minimum X. In other words, we want to build up a function of X, function of something. We must find the independent variable from that function we can minimize or maximize. Well, okay, may I start now? Now we're looking for a variable which determines the length of X, the X of the red line. Okay, the red line must touch this piece of wall, must touch this piece of wall, and must touch this point. So we can divide the line into two parts, right? So this is a 3, this is a 2, okay. And I'm using variable this angle. I choose this angle as my variable. So this is also theta, right? This is also theta. I hope you can see it clearly. Theta. And this theta determines the length of x. X is the length of the red line. Now, once you choose a proper variable, the function is not difficult to establish. So x is equal to this piece of length, this hypotenuse of triangle, plus this hypotenuse of that triangle, right? Yeah, so in this triangle, the hypotenuse is 3 times cosecant theta, right? This piece. And this piece, hypotenuse in this triangle, is 2 times secant theta. Okay. And theta is from 0 to half pi, right? If theta is 0, that means the length of the red line is infinity. And if the theta is a half pi, and the length of the red line is infinity. So therefore, we don't have a maximum value of the length of the red line. We have only minimum value. So in other words, when we find this critical point, critical value for x must be minimum. This minimum length is actually the longest post we can carry it over horizontally through this corner without tilting. So, okay, I think enough to explain this. So this is 3, right? So once you establish function, then the follow-up is just trivial, you know, to find the optimal value of x is find a derivative, right? So the derivative of x with respect to theta is equal to negative, right? This is a 3 cosecant x cotangent x plus secant derivative. Secant derivative is secant and a 10, right? Okay, we let this be 0 and let this be 0, and which means we change it to sine and cosine, right? So this one is then negative 3 cosine theta over sine square theta plus 2 sine theta over cosine square theta equal to 0. You know, the calculation is trivial. The establishing the function is the most important step. So from which that we can find let me jump over these kind of calculations. So tangent cube theta is equal to 3 over 2, right? So tangent theta is equal to cube root 3 over 2. So tangent well, I hope my calculation is correct, you know. If something is wrong, please leave your comment, right? And from which that theta is equal to 0.85277, and then we can find x, right? X is equal to this is theta is equal to 0.85277. So this is equal to 3 cosecant theta plus 2 secant theta, and is equal to 7.0235, and so approximately the longest the post can be carried over this corner is 7 meters. Okay, so this must be minimum. Why? Because the maximum is not existing. See, the x could be, the length of this red line could be infinitely long. So the value we find must be minimum. This minimum is the longest this post can be carried over the corner. Right? Well, I just emphasized it 3 times now. So by answer that, the longest the longest post is 7 meters. Well, approximately 7 point a little. Well, hope you like it. Now, if my calculation is something wrong, please leave your comment. All right. I think the method must be correct. Okay. Thank you for your watching.